In this section, we want to take a look at a topic called analysis of variance. We have seen working with a single mean. We've seen the analyses for that. We've seen comparing two means. Now we want to compare three or more means. And before we can get into the analysis, we have to go ahead and take a look at some definitions. The terminology with the analysis of variance is a little strange, primarily because of where the analysis of variance techniques got their start. They were mostly in an agricultural setting. And the setting would be some farmers were working the farm and they were trying to grow more crops, and they were trying to come up with ways and share knowledge of how to do that. And so imagine, if you will, that I'm at home, and over the last several years I've gotten into the farming life, maybe a little bit more than most people. Maybe my wife and I want to grow some tomatoes. And we're really interested in growing tomatoes. But when you try to farm, there's obviously factors that are working against you. There's some things that you need to take into consideration. There's pests, there's watering amounts, there's fertilizers, there's a whole bunch of different stuff. And so let's take a look at these definitions, and I'll talk about it in the context of maybe that kind of setting. So let's start with the response variable. Later on, we're going to call this the dependent variable when we get to our regression analysis. But the response variable is the variable that we want to measure. That's what we're really interested in learning about. And sometimes we're interested in maximizing this, in other situations, maybe minimizing that. But in general, that's the quantitative piece that we want to work with. And so in my example, if we're going to be working with tomato plants, we want to get the most tomatoes that we possibly can. And so maybe we'll call it tomato yield, maybe the weight of the tomatoes that we produce for a particular, say, plot of land or a plant or whatever measure you want to think about measuring, whatever unit of measurement you're working with. We want to maximize the yield. And so that'll be our response variable, the thing that we're interested in learning about. So that's the first one. Then you have what are called various factors. And again, later on, I'm going to call these independent variables when we get to regression analysis and analysis of variance, response variables and factors. These are the variables that we can control. These are things that I have a little bit of control over, maybe a lot of bit of control over, that will hopefully help us to either minimize or maximize the response variable. In my tomato example, I want more tomatoes. I don't want less, I want more. And so what can I do to influence tomato growth? Those are going to be the factors. And so the watering amount. And now I know, because I do grow some tomatoes at the house, I know that there's certain things that I can control and certain things I can't. Like the watering amount, I have some control over. Earlier this year, I'm filming this in June. Earlier this year, we had a very dry part of the season. We didn't have a whole lot of rain. And so any kind of watering had to come from me. I had to create some systems or take the time every day to go out. And I use the word me loosely. My wife does most of this for me, or for us, I should say. But we had to provide the water. But we had that ability. We could go out and we could add water whenever we wanted to. And other times of the season, over the last several weeks, for instance, we've been getting a lot of rain. And so we're not having to do it ourselves, but sometimes you can get too much rain. Now, again, there's some things you can control by raising the bed so it drains real well. And that's kind of beyond the scope of what we're talking about now. But the main thing here is the watering amount is a factor. The fertilizer that we choose to use or not use. We try to grow things kind of organically, so we don't use a lot of extra fertilizer. We compost, but we don't put a lot of extra stuff on. But the type of fertilizer or non-fertilizer, that'd be a factor. That'd be something I can control. And so there are different variables in play that we have control over. Those are called factors. And the idea is, how do we manipulate those factors to affect the response variable? All right, so response variable is the one we're interested in learning about. The factors are the ones that we have control over. The levels of the factors are something we need to be aware of. So the watering amount. The watering amount could be very scientific, very specific in terms of a numerical. For our purposes, I'm going to let those factors be just qualitative. So we're going to think about watering levels, high, medium, and low. We'll talk fertilizer types, 1, 2, or no fertilizer. And so you have various levels of the individual factors. we can see, and really, I'm talking about analysis of variance now. I know I'm going to move to regression analysis later. There's an overlap. We can do the analysis of variance for the most part using our regression analysis tools that we learn later. Um, but there are some benefits of working with the analysis of variance now, so we're going to talk about it. So factor levels, the various settings of the individual factors, and that gets us to ultimately what we're interested in, and those are called treatments, combinations of the factor levels of the various factors. And our goal in the analysis of variance is to compare treatment means. I want to figure out if fertilizer 1 and low watering amount produces more or less tomatoes than fertilizer 2 and high watering amounts. And as I mentioned, sometimes the weather dictates my watering amount. Sometimes I don't have a choice. We're getting a lot of rain right now. I don't have a choice whether I can't use low watering amount. I can't protect my tomatoes that well. And so if a certain fertilizer works better with high watering amounts, and I'm a fertilizer person, that would be the one I would want to use right now. In the drier parts of the season, maybe I would change my opinion. And that's really what this is about, trying to learn from experience. Set up an experiment, design an experiment so that we know what we should expect to happen. There's always variation. But if I have the most knowledge I can, then I got the best shot at getting more tomatoes. And that's ultimately what's going to make me happy. All right, so the goal of analysis of variance is to compare treatment means. I'm going to give you two examples of various designs, if you will. The first one, we're interested in comparing the average Stat 2 grades of students from various majors within the College of Business. As I'm filming this, I'm thinking, gosh, I wish I would have thought of this in terms of, I want to compare the average Stat 2 grade based on the different ways that the course is presented, whether it's a purely live class, an online class, or a hybrid class. But I'm going to use this example, similar example. I want to see who does better in Stat 2. Is there a difference within the various majors in the College of Business? So in this particular example, the response variable, the thing I'm interested in is the Stat 2 grade. That's the quantitative piece I can measure. At the end of the semester, I can take a look at what your majors. I have your majors. On your rolls, it tells on the class roll, it tells me what the major of each of the students is, and so I could classify you based on what is on the student rolls, and then compare. What's the Stat 2 grade of the information systems students? How about the finance students? So the response variable is the actual grades themselves. The factors are the majors. Whereas the only factor in this one is the major, I should say. And then the different levels are the different majors within the college: marketing, finance, information systems, accounting, etc. And so when there's only one factor, the factor levels and the treatments are the same. Think about the definition for treatments I just gave you. Treatments are the combinations of the various factor levels. Well, there's only one factor, so the treatments are the factor levels. This is referred to as a one-factor analysis, and our goal is to compare the means, the mean grade of the marketing majors, the mean grade of the finance majors, the mean grade of the ISDS, the mean grade of the accounting majors. Okay, the null and the alternative that we're going to set up look like this. The null is going to say, think about what we did when we had two means. We said mu1 and mu2 were the same. Now we're going to say all the means are the same, and the alternative is going to say, at least two means differ from one another. And as I mentioned just a second ago, this is referred to as a one-way referring to the number of factors. The other name we'll give to this is a completely randomized design. You're going to get some experience with this design. I'm going to have you do some work in your projects working with a one-way or a completely randomized design. Completely randomized design is probably the most common name. When you get to your software, you're going to look for a one-way analysis of variance, or a one-way AOV is what it'll show up actually in the menus. And I'll create another video showing you how to get the printouts that you want. But this is a one-way study. Now, if I add another factor, this example, you get not a one-way study, but another name for it would be, of course, a two-way study. We're interested in modeling the salaries of USF professors based on their ranks. USF professors, there are full, there are associate, and there are assistant. And not in that order. Full, assistant, and associate, I believe, is the order. Full professors are the more experienced, the higher paid. Associate or assistants in the middle, and associate is the lower tier. And then the gender, male and female. Okay. Now, a lot of times you hear discussions about, is there salary discrimination for females? Do females make less than males? Well, you can't just compare one female's salary to a male's salary. You got to consider other factors. As we move further along in the class, does the years of experience matter? Of course it does. Yeah, there's other factors. But here, let's just talk about these two different factors here, the rank and the gender. So again, going through the definitions, the response variable is going to be the salary. And I have two factors now. I have factor 1, which would be the rank. I have factor 2, which would be the gender. And of course, the different levels, the full, the assistant, the associate, the male, the female, those would be called the factor levels. But there's two of them. And now to get to treatments, we look at the combinations. And so if you have 3 treatment levels, or excuse me, let me say it again, 3 factor levels for factor 1, and you have 2 factor levels for factor 2. Sometimes this is referred to as a 3x2 design. 3 levels here, right? We have 3 levels here, and 2 levels here, and sometimes it's an awful looking 2. 3 times 2 is 6. There's going to be 6 treatments, and here they are. It's just mixing and matching. You do full with male, full with female. You do assistant with male, assistant with female. You do associate with male, associate with female, and you get your 6 treatment means. Again, our goal is still to compare the treatment means. It's just this is a more difficult analysis. It's called a two-way analysis, or sometimes referred to as a factorial design. And in fact, I would refer to it, as I mentioned earlier, a 3x2 factorial design. That's kind of the way that it would be talked about or spoken about. And so this is a much harder analysis because now in addition to having an extra factor, we're going to have another idea called, I'm going to throw this idea out, we're not going to look at it now, but it's called interaction. And probably the better example would be my tomato example. If you think about it, I already mentioned this idea. When you're working with specific types of plants, you know, tomatoes are one plant, but maybe you have beans, and maybe you have corn, and maybe you have something else. Certain plants like a lot of water, and certain plants don't like a lot of water. That's why you plant them in different seasons. That's one of the reasons. Same thing with heat and sunshine. So sometimes it's an easy call with the factors. It's like, oh, high watering is the best for that plant right there. And we know that's going to be the case. But sometimes that's not the case. For instance, the fertilizer type. Perhaps one of the fertilizers, it's not always fertilizer 1 is the best fertilizer to use on corn. Maybe that's not the case. Maybe fertilizer 1 is the best fertilizer to use on corn if there's a lot of water, and fertilizer 2 is a better fertilizer if you're in a drought or there's not a lot of water. And so maybe the relationship between the factors depends on each other. And the way I would say it, maybe the relationship between the response variable and one of the factors depends on what the other factor is set at. Now, if that idea made sense, that's great. If it didn't make sense, no worries. We're going to catch it later on. We're going to look at the interaction idea, and that's the idea I was talking about there. We're going to talk about that idea when we get to our regression work. So I'm going to work with the interaction. I'm going to introduce the idea. We'll catch it later. The main thing now is to say this about the factorial design. It is much harder. That interaction idea becomes kind of a big deal. You're only going to be responsible for the one-way analysis this semester, but in this introductory video to this part of the course, I wanted to mention that this experimental design can of worms that I'm opening, it gets harder. It gets more difficult, more complicated, I guess is the best way of saying it. We're going to look at the one-way analysis, the completely randomized design, and that's the one that you're going to get a little bit of work with. On your projects, I'll do some examples, and I'm going to talk you through that. But I did want to introduce a more complicated, the factorial design here, a more complicated design, so that you get a taste for it. So that's a good introduction. I'm going to stop there. It makes sense because the next step is to take a little bit of closer look at this completely randomized design and kind of break it down, talk about it, and see where you go. One thing I will say, this is going to be, I'll save this. I'll save that topic or that conversation for the next video. So anyway, hopefully that's a good introduction to experimental design, get some of the terminology, make sure you know the difference between response variables and factors and treatments. And I'll talk to you soon with the completely randomized design. So long.